All right, so today is the 18th. We're going to do the warm up. We're going to do some note cards again on laws of exponents. Then we're going to work on multiplying and dividing, scientific notation, and work on scientific. Homework, we already labeled as Wednesday's problems in the packet. And yes, there's another homework help video. I'm going to pause to give you a chance to write. All right, planner. We already started our EOG review with the note cards yesterday. We started with writing the formulas. All right, so math 8. We have homework. We have homework help video. And we need to study our note cards. Bless you.
Bless you.
And notes. Please feel free to study your notes in your interactive notebook. Okay, we know we have EOG coming up. We need to be looking over our notes, reading our notes to make sure we understand stuff. Pause to give you a chance to write. Let's do the warm-up. Move the cursor out the way. All right, so look, you have to simplify the top and then divide. So it's multiply, because this is multiplication between the parentheses, and then we're going to divide, okay? This may be calculated inactive, so let's try to do a calculated inactive, and then I'll show you how to type it in. All right, so let's multiply. Remember, you multiply the numbers first, so out to the side. I have 3 times 4. What's 3 times 4? 12. Okay, so I got 12. All right, and then I multiply these together. So this is 10 to the 5th times 10 to the negative 7. And remember, when you multiply exponents with like bases, you're just adding the exponents. So that's 5 plus a negative 7. What's 5 plus a negative 7? Negative 2. So we got times 10 to the negative 2 power. Okay? This is not in scientific notation. I need you to understand that, because you're going to see something like this. So I have to locate the decimal and move it behind the first significant digit. In order for it to be in scientific notation, that decimal has to be behind that first number. So this 12 is bigger than 1, so I know I'm going to add to move my decimal. So I'm going to move my decimal 1 time to get it behind the decimal. So this is plus 1. Okay, and I should have did that to the side. Okay. So on top, this new numerator is now going to be 1.2 times 10 to the negative 1. Okay. Divided by, on the bottom, this is 6.0 or 6 times 10 to the negative 2. All right, so now I'm going to divide the numbers and subtract the exponents, because that's how you divide when you have like bases with exponents. So let's divide. We have here, do this out to the side, divided by 6. 6 won't go into 1, but it will go into 12. How many times will 6 go into 12? Twice, 2 times. That gives me 12, 0 remaining. Bring up the decimal. So now what I have there is 0.2. I'm going to subtract the exponents here. So that's 10, because it's dividing. 10, negative 1 minus a negative 2. What's negative 1 minus a negative 2? Positive 1. So that's 10 to the positive 1. So this is going to be 0.2 times 10 to the positive 1. Okay, so look at that. It's not written in scientific notation because the decimal's in the wrong place. It needs to be behind the 2 and not in front. This number right here, 0.2, is smaller than 1, so I have to subtract to move that decimal. So I'm going to move it 1 time, so I subtract 1. What is 1 minus 1? 0. So this is 2, move the decimal over, it's right here, times 10 to the 0 power, or just 2. Because any number to the 0 power is 1. 2 times 1 is 2. So either or is going to be the answer. Okay? Any questions? I'm going to pause for the calls, give you a chance to write and process, okay? All right, so look at this. It says 2 joggers run 8 miles north. Okay, so north is up. So they go up 8 miles. So that means I'm going to draw a line going up north from here to here. It's 8 miles. Okay, and then west. West is to the left. So they travel 5 miles west. I'll put 5 miles here. West is to the left. What is the shortest distance? And they want you to round it to the nearest tenth. The shortest distance, instead of going here to here, is to go straight from where you start to where now you need to be. So this is the side that we're looking for, okay? And if we draw it, we can see that this is a right triangle. So what do we use to find this missing length of a right triangle? What do we use?
Pythagorean theorem.
Pythagorean theorem. What is the formula for Pythagorean theorem?
X squared plus b squared equals c squared.
Equals c squared. So now our legs, our A and our B, are the sides that actually form the right angle. So these are your A and B. This is A, this is B. So we got 5 squared plus 8 squared equals c squared, okay? So now, let's do 5 squared. What's 5 times 5?
25.
25. And what's 8 times 8?
64.
64 is equal to c squared. So now we're going to add these together. We have 25 plus 64. What's 25 plus 64?
89.
Very good. It is 89. So we got 89.
I'll just shut up. Please.
Just do it.
Guys, please stop doing that. Okay, so now what is the opposite of squaring a number?
Square root.
Square root. Okay, so we got square root. So let's type in the square root of 89. Second x squared and 89. Let's round that to the nearest tenth place because it's asking for the nearest tenth of a mile. All right, so what is that answer to the nearest tenth?
90. 90.
Not 90, no.
The nearest 10.
Yeah, did you type in the square root? Very good, baby. 9.4. So it's about, we put the squigglies, about 9.4. See? Nearest tenth is 1 space behind the decimal. All right, I'm going to pause, make sure, if you have any questions, please raise your hand. Any questions? Yes, ma'am.
How do you square root again?
You press the second button and x squared.
Okay.
Got it? Any other questions? Yes, ma'am. Mm-hmm. Yeah. Give me a second, please. Do that at the end. I don't want you to get behind. Anybody else? All right, let's take out our note cards, please. You have your area formulas. Your area formulas are on the back. This is note card number 1. Area of a square, s to the second power, rectangle, length times width, circle, pi r squared, parallelogram, base times height, triangle, 1/2 base times height, trapezoid, 1/2 height, b1 plus b2. That's the first note card. Please put 1 on that note card. 1. Volume. This is the second note card. Volume, hey babe. This is the second note card. Q, S to the third power. Q, S to the third power. Rectangle, length times width times height. Length times width times height. This is a rectangular prism. Cylinder, pi r squared times height. Pi r squared times height. Cone, 1/3 pi r squared times height. 1/3 pi r squared times height. We got a sphere, 4/3 pi r to the third power. 4/3 pi r to the third power. 4/3 pi r to the third power. These are your volumes. This is your second note card. Pythagorean theorem is the third note card. Put a 3 in the corner, please. Pythagorean theorem is the third note card. A squared plus B squared equals C squared. Where your A and your B are the legs, that's the side that forms the right angle. The side opposite of the right angle is your C, which is called your hypotenuse. 3, card number 3. Card 4 is slope. Card 4 is slope. There are 2 formulas for slope. Rise over run, and M is equal to Y2 minus Y1 over X2 minus X1. When do you use rise over run? When they give you a graph, a line, or if they ask you to find the slope of a picture or a ramp. That's when you use rise over run. When do you use Y2 minus Y1 over X2 minus X1? When you're given a whole table values, when you're given X and Y values, pick only 2 of them. Or if they already give you the 2 points, use this. And if they ask you to find rate of change and slope is the same thing. Let's put or rate of change.
These on the note cards?
Yes, ma'am.
That's it.
Okay, make sure you make that correction. We're adding or rate of change. I'm gonna pause for the calls. Please write it. This is the 4th note card. The 5th note card, slope intercept form. Linear, this is for linear equations. This is what most linear equations look like. Not all, but most. Okay. Slope intercept form. Y equals mx plus b. Where the number that's attached to x is the slope or the rate of change. Slope and rate of change, they have the same meaning. And your b, the number that has no variable attached to it, is your starting amount, your initial value, or the y-intercept, where the line crosses the y-axis. Let's write that down. Where the line crosses the y-axis. Okay, this is on the 5th note card. Pause to give you a chance to write where the line crosses the y-axis. All right, these are the different kinds or types of slope. This is the 6th note card. Types of slopes. Okay. This is the 6th note card. Pause for the pause. All right, here we go. First type of slope, we got positive slope. Positive slopes are where as x increases, y increases. Let's draw a coordinate plane. Those are lines that from left to right, they go up. This is a positive slope. That means your m is going to be a positive number. Your rise over run, it's going to be a positive number. Negative slope draw a coordinate plane. That's where, as you read from left to right, X always gonna increase because you always read the X axis from left to right. But as you go from left to right, as X increases, Y is decreasing. That means your line is going down from left to right. X is always gonna increase. X always increases. But Y is gonna decrease. That means your line is going from left to right, your line goes down. That means your M is going to be a negative number. M here is a positive number. M here for this line is going to be a negative number. Any questions? Okay. The next kind of slope is zero slope. Zero slope means that there's no steepness to the line. It's a flat line. This is what this looks like. You're almost guaranteed to see a question like this, okay? This is your coordinate plane. Your zero slope is a line that just lays flat. It's a flat line. This line right here is a flat line. It is a horizontal line. Horizontal lines have zero slopes. That means M here is equal to 0. It's a flat line. M for flat lines are 0. It has no steepness to it. The last kind of slope is undefined. Undefined slopes are vertical lines. Straight up and down vertical lines, okay? This line right here has undefined slope. That means M here has a number on top, and well, 0 on top and a number on top, say right first time, and 0 on the bottom.
Can you zoom in a little bit?
Zoom in.
Mm-hmm.
Give me a second, okay? This right where you have a number on top and 0 on the bottom, M is undefined. Straight up and down line is undefined. I'll pause for the pause. Take out your sheet from yesterday on scientific notation. Please make sure that you put your note card safe place. Put it on the key ring. If you don't have a key ring, I gave you one once before. Please try to locate that key ring, or you can just, they're really, really cheap. Walmart, Amazon, they're really, really cheap. Yes.
I wasn't hearing it.
You need another note card?
No, I need the paper.
The note card here, oh, the paper from yesterday. Do you need, make sure you go back and watch the video so you can get the note cards. Because the note cards are going to be a project grade, okay? Can you pass this over? Those are note cards from yesterday. Yes, baby, that's it. All right. So we started working on division. Yes, baby. Can you pass this? Put your phone up, okay? Can you pass this back? All right, so here we go. We're doing division. All right, we're doing these by hand, and then I'll show you how to type them in, okay? We're gonna do them by hand. All right, so first things first, we need to write the top number in scientific notation, okay? When you're writing numbers in scientific notation, first step is to locate the decimal. Where is the decimal if you don't see it? Behind the last number. Remember, commas and decimals are not the same. Commas help you read place values. Okay? All right. We're going to move this decimal behind the first significant digit. As we read this number from left to right, like we're reading a book, what's the first digit that has value? 5. So let's count to see how many spaces we have to move that decimal to get it behind 5. 1, 2, 3, 4, 5, 6. So I'll pull a 6 in the corner so I can remind myself that it's 6. So this is going to give me 5.0 times 10 to the what power?
6.
The positive 6 power. Why positive 6 and not negative 6? Why is the exponent positive and not negative? Huh? Because it's what? Yeah, we did. And what's another reason? That is correct. What's the other reason? Because it's a big number. Because it's bigger than 1. It's a big number. Okay? All right. So let's look at this one. It's already written in scientific notation. All right. So now let's divide. Okay? We're going to divide out to the side like we did over here. 5 is on top. So we got 5. Move this over. Sorry, y'all. We got 5.0. And we got 2.5. When you are multiplying decimals and the divisor, doesn't matter about the dividend, but the divisor is a decimal, you need to move the decimal behind the last number. So we're going to move it one time here. If we move it one time here, we got to also move it one time in the dividend. So now what we have is 25 divided by 50. How many times will 25 go into 50? 2 times. Very good. So this gives me 50 with 0 remaining. Okay, so far I have 2. So now I'm going to divide this. When I divide that out to the side, I have 10 to the 6th power times 10. I'm sorry, divided by. Sorry, y'all. Divided by 10 to the 3rd. What do I do with the exponents when I divide? Subtract them. What minus what? Top exponent minus bottom exponent. And what does that give me? 10 to the what?
3.
To the 3rd power. So when I put these together, this is going to be 2.0 or 2 times 10 to the 3rd power. That's my answer in scientific notation. Questions about that? I'm going to pause because I see some people that are still writing. All right, let's do it. Okay, so now we want to take this number that's written in scientific notation and write it in standard form. Is the standard form of this number going to be a big number or is it going to be a small number? It's going to be a big number. Why? How do we know that?
Because the exponent is positive.
This exponent is positive. So which direction do we have to move this decimal? Do we move it to the left or to the right?
Right.
Right, to make it bigger. So this is 2.0, and we move it 1, 2, 3 times. What do we put as placeholders? And this is our answer. 2,000. See if you can do number 6 on your own. Let's divide, subtract the exponents. I'm going to pause to give you time to do number 6 on your own. Okay, good folks. Let's look at it. Here we're going to divide the numbers. Long division. We have 9 here. We have 1.5 here. Okay, again, you're going to have to move the decimal. This divisor cannot be a decimal. Move it behind 5. Make it a whole number. So if you do that here for the divisor, you have to do the same thing for the dividend. The decimal is behind the last number, so you don't see it, and move it one time. So you have to put a 0 here. So now what we have is 15 divided by 90. Okay? How many times will 15 go into 90? 15 times what will give me 90? Anybody know? Think of smaller. How many times? Say again? 6. Okay? 6 times 15 will give me 90. Okay? So I have 6 so far. So now I need to divide the exponents here. We got 10 to the 11th power divided by 10 to the 7th power. Okay? So now, what do we do with the exponents when we divide with like bases? Subtract. What are we subtracting? What minus what? 11 minus 7. What's 11 minus 7?
4.
It's 4. So how do I write this answer in scientific notation? What times what to the what power? Come on, Drew. Somebody said it. Please say it louder. 6.
6.0 times 10 to the 4th.
Very good. Okay. Very good, babe. All right, now we got to write this number in standard form. Is our answer going to be a big number or a small number? It's big. How do we know it's going to be a big number?
Because the 4 is not negative, it's positive.
Very good, because the 4 is a positive number. So are we going to move this decimal to the right to make it bigger, or move it to the left to make it smaller?
Right.
To right. 1, 2, 3, 4. What do we put as placeholders here?
0.
So we have 60,000. Questions? All right, so let's look at the bottom. All right, number 7, let's do this one together. It says there are approximately, and this number right here, households in the United States, okay? If the average household holds 40 gallons of water each day, 400 gallons of water each day, what is the total number of gallons of water used by the household each day? Okay, so what do we do to figure that out? If this is how many households there are, and each of them hold 400 gallons, how do you figure out the total of gallons of water in the United States? The total. How do we do that? Pause for cause, give us a chance to think. You will multiply here. You're going to multiply how many households there are. 1.2 times 10 to the 8th power. Okay, that's how many households. A lot of households. That's why you see that, look, that 8, that's a big number. You move it 8 times. And you're going to multiply it times, each of them have used 400 gallons every day. Okay? So now this is where we're going to just type it in the calculator to get our answer. If I wanted to do scientific notation for this, I could, like I did up here with these. And I could write it as, and I'm going to show you how to do it just in case you have a problem like this on your test. Locate the decimal, move it behind the 4. So this is going to be 4.0 times 10 to the what power? How many times I move that decimal? 2 times. Okay, so now I'm going to show you how to type this in the calculator and write it in scientific notation. Okay, clear your calculator. 2 plus 7, 1, 2. Mine says it's almost dead, but I use it until it dies. Okay. All right, I do have batteries, so if it dies, just let me know. Okay, so now I'm gonna put it in parentheses. I'm gonna type this one in first. 1.2. Please do this with me because you'll see it again. Then type in times 10, caret key. Look, don't forget, this is the caret key or exponent button. 8th power. Close the parentheses. That's this. Then we got times, parentheses, let's do the second one. 4, you can put 0.0 or you can just put 4, times 10, caret key, 2nd power. Mine died. Can I see yours? Did you type it in? Okay. Times 10 here, caret key, and it's to the 2nd power. Close the parentheses, okay? And this is supposed to be a parentheses up here. Okay? This is supposed to be a parentheses over here. He got brackets in my parentheses.
Do we hit measure?
All right, got it? All right, so now we want this in scientific notation. So we're gonna press the mode button and convert it from normal to scientific. Press enter on SCI, that's important. Now you can go back to the main screen, second mode, and press enter. And he still has a bracket, so let me change that. Parentheses, and press enter. So this is 4.8, the E stands for times 10. So the E, when you see that, when you see this 4.8 E 10, this E right here represents times 10. So this is going to be 4.8 times 10, and the number that's after the E is the exponent, so that's to the 10th power. Of course, if you want it normal, if you want the actual number, then go back to mode and put it back on normal, and then press enter, and it gives you, well, the answer's so big, moving it 10 times is a lot. So it's automatically putting it in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a big number because it's a positive exponent. I put 0 here as placeholders. Okay. So this is a big number. 1, 2, 3 zeros, a comma, 1, 2, 3 zeros, a comma, 1, 2, 3 zeros, a comma. See that? So 48 billion, right? Any questions? All right, let's do the next one. The population of China, it's a lot of people in China, y'all. The population in China is about 1.4 times 10 to the 9th power people. That's how many people there are. While the population in South Korea is approximately 50 million people, okay? How much or how many times greater? So you want to know how many times greater, not the difference, okay? Or how many more, that's subtracting. You want to know how many times greater it is, okay? What can you multiply times this to give you that? That's what you want to know. So you got to do the opposite of multiplication and divide to figure out how many times greater. So we're going to write this in scientific notation. Okay, which one of these numbers is bigger? This one is bigger. China right now is like the richest right now. It's China, Japan, and then U.S. Something like, yeah, China, Japan, then U.S. And then it's Russia. Russia is after that. Okay? But China is like one of the most powerful. They're like beating us right now as far as money. All right, this goes on the bottom, so we want to write that in scientific notation. All right, so your decimal goes here, and you move it behind what number? What's the first significant digit?
5.
The 5. So let's count how many times we move it to get behind the 5. 1, 2, 3, 4, 5, 6, 7. Okay? So this is going to be 5.0 times 10 to the what power?
7.
7, because you moved it 7 times. This number is smaller, y'all. And you can tell it's smaller because the exponent is smaller than 9. So now I want to type this in the calculator. So we have parentheses, 1.4 times 10, caret key 9, close the parentheses. Oops. Sorry about that. And then we do divided by parentheses. Somebody has scratched these things off. That's not good. That's fine. It's just kind of dumb because now if you get this calculator, you can't. I know where things are, but it's easy to press the wrong thing because you can't see what the buttons are. 5 times 10 to the 7th. And you want it in scientific notation mode. Go over to scientific, enter. How do you get back to the main screen, Ms. Rez? Second mode. And press enter. So this gives you 2.8E1. What does the E stand for again?
10.
Times 10. So this is going to be 2.8 times 10 to the 1 power. So that means you move the decimal 1 time. So this is going to be just 28. So it's 28 times bigger. That's a lot. Okay. All right, good folks. Keep up with your note cards, please. It's a project grade. Please keep up with those note cards. If you don't have a key ring, they're really cheap. You can get them at the store, okay? Because you've gotten one from me before, but it's close.